Hey guys, welcome to the worked answers for the 2018 Level 2 Algebra paper. Let's get into it. So, question 1a. We've been asked to simplify fully this expression here, 25m to the power of 16, all raised to the power of 1/2. So we've got 25m 16, and that's all raised to the power of 1/2. Now the first thing to note is we've got fractional indices here, and they are in the form power over root, so that might come in handy. Basically, each term inside our brackets is being raised to this 1/2, and so we can say, the first thing we can say is 25 to the power of 1/2 times m to the power of 16, and we've got powers on power, so it's going to be 16 times 1/2. For the 25, we are going to use our power over root rule, and we're going to say this is root 25. And we've got m, 16 times 1/2 is 8, and so it becomes 25, not 25, 5 m 8 here. So correct answer gets you an achieved grade. Question 1b, simplify fully this expression, 4 over 3a, all raised to the power of -2 this time, leaving your answer with a positive index. So 4 over 3a, all raised, and we could tidy up this 4, all raised to the power of -2. Another one of our power rules, negative indices. The way we tackle that is by flipping our fraction, so flipping everything inside the brackets. So we've got 3a over 4, and with that we can raise this to the power of +2 now. And so it's just the same principle as last time. You've got 3 squared times a, and it's got an invisible 1 for a power, and that's times 2. And this is over 4 squared. So simplifying this, we've got 9a squared over 16. And so again, correct answer gets you the achieved grade here. Sweet. Moving on to question 1c. It says write 4 minus this fraction b plus ac over 3c as a single fraction in its simplest form. So we've got 4 minus, as always, we just write out our expression. And so here we are going to be cross multiplying here, and what I mean by that is multiplying diagonally like this, and also multiplying our denominators. So we've got 4 times 3c is 12c, and we could even keep it as single fractions just to show this process here. And so our denominator is going to be 1 times 3c, which is 3c, and this is minus 1 times b plus 8c, so just b plus 8c. Okay, and that's inside brackets, and its denominator is again 3c. And so we can combine fractions here because we've got the same denominator. We can say 12c, and at the same time let's expand these brackets, so it becomes minus b minus 8c, and this is all over 3c. We can collect like terms, so we've got, in the numerator, we've got terms with c in them. So 12c minus 8c is 4c, minus b, and over 3c. Okay, final simplification, 4c minus b over 3c. This gets you a merit grade. Your achieved fractions written with a common denominator. So I guess this step here would get you an achieved. Question 1d now. Factorize fully this expression, 4bx plus 2xy minus 6ab minus 3ay. Okay. 4bx plus 2xy minus 6ab minus 3ay. And here we've got 4 terms. We're trying to factorize this expression. If we think of when we go about factorizing quadratics, and we haven't had to do that yet in this paper, but you've got ax squared, and we would have split our b term, right? So 2 terms in there, and then you've got plus c. And we would, at this point, we would half, so split the term. We would factorize the left-hand side and factorize the right-hand side. We are basically going to use the same process here. So we've got 4 terms here, and so let's draw our line through the middle of the expression, and let's factorize the left-hand side. We've got a common factor of 2x, and then inside the brackets, b, 2b that is, plus y. Okay, I hope that makes sense. For our right-hand side, we've got a common factor of minus 3a, and inside the brackets, 2b plus y. And this is the same for factorizing quadratics, and it's something I say every time. If your 2 sets of brackets are the same, in this case 2b plus y, then you know you're on the right track. So we can say 2x minus 3a becomes a factor, and our second factor is 2b plus y. And with that, we have factorized completely. So correct factorization here, 2x minus 3a times 2b plus y. That gets you an achieved grade. Okay, moving on to question 1e. It says a rectangular box has no lid. The length of the base is 60 centimeters. Its height is 1/4 of the sum of its width and length. Okay, and the total area of the base and the 4 sides, so the sum is 7,400 centimeters squared, and we've been asked to find the height of the box. So that's a lot of information. This diagram here is going to be crucial. We can see some dimensions: the height h, width w, and as mentioned, the length is 60. So we've been asked to, again, find the height of the box. So we're trying to find h here. What do we know? Well, yeah, let's go about just jotting down some of the information. No lid is something to be aware of. Length is 60, so we could say, I guess, just L equals 60. Height is 1/4. So I'm looking at this step here. Its height is 1/4 of the sum of its width and length. And so we can say h equals 1/4 of the sum of its width and length. So w plus, and we know the length, it's 60. And this is inside brackets. So that's our expression for w. And now this area information, total area of the base and the 4 sides. At first I read it as area of the base plus, I'm not sure what I was thinking. I guess length of the 4 sides. That's not true. Basically, area of the base and the 4 sides. Just got to be careful how you interpret that. Is 7,400. So let's establish an equation for that. We need the area of the base, and we could actually write that out first of all. Area base plus area 4 sides. Now the 4 sides are actually, they're not all the same, are they? Because we're working with a rectangle. For the moment, let's just say 4 sides, just to sort of put our question into an expression. 4 sides. equals 7,400. So we need to substitute some side lengths in here, some dimensions. So area of the base, well, and actually let's scroll back up slightly. Area of the base, that is, if I can highlight it, that is in here. That's our base. And what is its dimensions? Obviously, area of any four-sided shape is base times height. And so area of the base here is going to be 60 times W. So 60 W, let's say. And this is plus. Now, area of the four sides, we've got, looking at the front and back as we look at it. So basically these lengths here, there's two of them, front and back, and let's also color code the remaining, so the two ends as we look at it, and they're in here as well. Obviously they're overlapping. Okay, so the area of the blue is going to be base times height again. Its base is 60, its height is h, and there's two of them, so let's say, we could say 2 times 60h. For now, let's say 60h plus 60h. Okay, now looking at the green, base times height, its base is going to be w, its height is h. We've got two of them, so hw plus hw. And this all equals 7,400, right? So this is our base here, and these are our four sides. And total area, again, 7,400. Okay. It's at this point we can tidy this up. We've got 60W plus, and we're collecting like terms, right? So we're adding the 60H's and the HW's. So it's 120H plus 2HW equals 7,400. And so what to do now? We could say, basically, we can't really go any further, and so at this point, let's look at our expression that we formed earlier on for h. H equals 1/4 W plus 60. So we can actually substitute that into our equation. So we've got, these are our h's that we're going to substitute. We've got 60W plus 120 times 1/4 W plus 60 plus 2, and let's say 2W, and now we'll substitute an H, so 1/4 W plus 60. Okay, we're getting there, and this equals 7,400. So we can multiply through, basically expand our brackets. We've got, again, 60W remains unchanged. And when I talk about expanding brackets, you're using the, well, I was going to say FOIL method. That's for expanding two sets of brackets, basically 4 terms in total. I was going to say multiplying, and I could even illustrate it real quickly. This is x plus a, x plus b. And so FOIL is first, outer, inner, and last. Here, let's just say you're multiplying everything inside the brackets by everything outside the brackets. So it's going to be 120 times 1/4 W and 120 times 60 here. So 120 times 1/4 1/4 of 120. What is that? We can calculate that. And actually, I have... Yeah, okay. Small mistake in here. Just looking at my notes. It's not h equals a quarter w plus 60, is it? H equals a quarter, and then inside brackets you've got this w plus 60. So we have to include that in our working. Let's just insert these brackets. And I have done that already here. Funnily enough, I have done the inside brackets, but not the outside brackets, so it's 2w times all of this. Okay. Anyway. So that means we have to take an extra step to basically expand what's inside these brackets. So initially I was going to go ahead and multiply 120, but we have to address this quarter w plus 60 first of all. So we've got 120 still on the outside, and that is multiplied by a quarter w plus 15. 60 over 4 is 15, plus 2w times a quarter w, and this is the same, a quarter w plus 15. So I've got a working in here, but that's alright. This still equals 7,400. Okay, at this point we can multiply through using that 120 and 2w. So we've got 60w plus, now 120 times a quarter, that's what we were originally working towards, that's 30, and it's 30w. 120 times 15 is going to be 1,800. Okay, and we've got plus, now 2 over 4, 2 over 4, that's 1/2, so it's going to be half, that's our coefficients. Looking at the w's here, it's going to be w times w, so half w squared, plus 2w times 15 is 30w, and this equals 7,400. Okay, at this point we can collect like terms, so we've got values of w, and the 30w here, we've got just our single, let's say integer terms, and we've also got this w squared here as well. So let's just tidy all this up. At the same time, we can put it in w squared plus w plus c form, so ax squared plus bx plus c is the quadratic equivalent in terms of x. We're going to say half w squared plus 60 plus 30 is 90, plus 30 is 120 w, and then 1,800, let's bring the 7,400 to the right hand side. We can see a quadratic here, and we want to bring everything to one side. We're going to say 1,800 minus 7,400, and that equals minus 5,600. Okay, and that equals 0. Now, we've got a quadratic. We can use our quadratic solver in our calculator. So we're gonna click mode, number 5 for equation, number 3 for quadratic, ax squared plus bx plus c equals 0. Your a term is going to be 1 over 2, b term 120, and c is negative 5,600. And so you come out with values of w equals 40 and negative 280. Now, one thing we know about w, if we pick it back up to our question, because we are working to a context here, meaning there's some constraints on our variables. W is a side length here. And so thinking about our values for W, obviously you can't have a negative side length, meaning W, you could say either can't be negative or must be positive. Let's just say must be positive. And so therefore W does not equal negative 280, and W equals 40 only. Okay, so value for W equals 40. What is the question actually asking us? It's asking us to find the height of the box, basically h. And we've been given this formula for h. It is h equals a quarter W plus 60. So let's write that out. H equals 1/4 W plus 60. H equals a quarter W plus 60 inside brackets. And so we've got our value for W. Let's substitute it in. H equals a quarter times 40 plus 60. So this is going to be a quarter times 100. And that means our value for h, the height of the box, is 25 here. Sweet. H equals 25 gets you the excellence grade here. Height found gets you an excellence. Your merit, it says, is quadratic formed. So I guess the step here gets you a merit. And your achieved expression for the height or the area formed. So your earliest achieved, just writing down the expression for the height, so here, or the area, I guess this step here is your area expression. So either or gets you an achieved here. Okay, moving on to question 1F, it says 3x plus y times x minus 12y minus 2x plus y times x minus 16y, this long expression here, can be written in the form a plus b all squared. Find expressions for a and b in terms of x or y. Okay, so I can just imagine this will be, again, a series of workings. We're going to be expanding our brackets, and hopefully at some point we can simplify down and come out with, basically write it in this form, a plus b all squared, and come out with the values for a and b in terms of x or y. So as always, we're just writing out our equation here. Our last bracket is x minus 16y. Okay, and so we are going to be expanding these brackets here. And here I can actually illustrate this FOIL method I was talking about. So multiplying first, that's messy, first, outer, inner, and last. And the same for these two sets of brackets as well. Okay, so we've got 3x times x is 3x squared. Negative 36xy plus xy, and possibly we should write out each term. Let's not simplify just yet. 36xy, x times y is just xy, and the c term, or the last term, is y times negative 12y, so not plus, but rather negative 12y squared. Okay, this is basically, this expression corresponds to our first two sets of brackets here. Now let's look at our last two sets of brackets. We've got, and we'll keep our negative sign as it is, and we'll just put this all inside brackets. 2x squared minus 32xy plus xy minus 16y squared. Okay, and that's inside brackets as well. Sweet. We can collect like terms here. Looking at our blue, we've got 3x squared minus 35xy and minus 12y squared. Let's do the same for our green, and let's also multiply through by this negative that we're working with here. So getting rid of our brackets essentially. We've got minus 2x squared. And first of all, let's say we've got minus 32xy plus xy, so that's minus 31xy. And that's being multiplied by negative 1, so it becomes positive 31xy. Hopefully that makes sense. And lastly, positive 16y squared. Okay, so let's collect like terms again. We've got terms with x squared. Where are we? Here. Terms with xy and terms with y squared. So it becomes x squared negative 35xy plus 31xy is negative 4xy, and negative 12y squared plus 16y squared is positive 4y squared. Okay, so we've narrowed it down into this expression here. They're asking us, or they say, it can be written in the form a plus b all squared, and I believe that's called perfect square form. And so I'm not really too sure how to explain this. Basically, we're working with square numbers, looking at our a and c terms. Let's say, what is the square root of those terms? Well, we've got x and 2y. And what is our operation going to be in the middle? Well, our b term is a negative. The c term may be a positive, but that's because it's a square number. Basically, inside the brackets, the operation is going to be negative, and this is all raised to the power of 2. Okay, and so we can say, because it's a plus b all squared, right? A corresponds with x, and b corresponds with negative 2y. And so it says find expressions for a and b in terms of x or y. So I guess we'll just say a equals x and b equals negative 2y. I guess, yeah, I think that's correct. So square completed and a and b identified correctly. That gets you the excellence grade here. You'll merit correct simplification. So I guess, yeah, this step here gets you a merit. Achieved correct expansion. We hadn't quite fully expanded on this step, so the third line of working, or third line in general, second line of working, is going to get you the achieved. Okay, that's us for question 1. Let's move on to question 2 now. So question 2, it says find x if log x 243 equals 5. So this is just a matter of knowing log rules. Log x 243 equals 5. And so we can say x to the power of 5 equals 243. We want to find x here, meaning x equals the fifth root, because that's the opposite of raising something to the power of 5, fifth root of 243. And what is that going to be? We can calculate that. Fifth root of 243. That is 3. So x equals 3 here, and that gets you an achieved grade. Question 2b, find m if log 3 times 4m minus 1 equals 2. Log 3 4m minus 1 inside brackets equals 2. So here, same principles, 3 to the power of 2 equals 4m minus 1. We can say 9 equals 4m minus 1. And let's now bring, basically making m the subject, so we can say 10 equals 4m. Divide by 4 on both sides, m equals 10 over 4. And this could be written in a number of ways, so I guess you could say 5 over 2, or 2.5 as well. Any of these answers gets you an achieved grade. Okay, moving on to question 2c. It says, find an expression 4x in terms of w if 3 to the power of 4x plus 1 over 9 to the power of x equals 27 to the power of w over 3. So 3 to the power of 4x plus 1 over 9 to the power of x equals 27 to the power of w over 3. Now this is basically an MCAT question, but it's, a step or two up, right? But the principles are the same. Whenever you see a question like this, where you've got terms with indices, you want to be working with the same base. And here, we can see base 3 is our first term, and we've got 9 and 27. We want to get all of these to base 3, because you'll recognize that 9 is obviously basically 3 to the power of 1 is 3, 3 to the power of 2 is 9, 3 to the power of 3 is 27. So that is more or less basic facts, and you'll be able to recognize that we're trying to, we want base 3 here. So that's the first thing we're going to do. We're going to say 3 to the power of 4x plus 1. That remains unchanged, but our denominator becomes 3 squared. And that's inside brackets, and this is raised to the original power of x. So to the power of x equals, and here we're going to say 3 cubed. So 3 cubed inside brackets raised to the power of w over 3. Okay. So we can simplify this. We can say 3 to the power of 4x plus 1, that's still unchanged, over, and we've got powers on powers, so we're going to be multiplying the powers, so it becomes 3 to the power of 2x. And this equals 3 to the power of, now 3 times w over 3, basically the 3 over 3 cancels, it becomes 1, and so it's just 3 to the power of w. Now another one of our indices rules. On the left hand side here we're dividing, meaning we subtract the indices. So 3, we can combine everything into base 3, we subtract the indices, so it's 4x plus 1 minus 2x, and so it's 2x plus 1. Okay, and let's rewrite that. 2x plus 1, not pi. Okay, that equals 3 to the power of w. And so a third indices rule and I guess this is why it is a level 2 question and not a level 1 question, we can say we've got two terms that equal each other, they have the same base, and so we can cancel the base and say that the powers that they're raised to, in this case 2x plus 1, equals w. And what is the question actually asking us to do here? Find an expression for x in terms of w. We've got an expression for w in terms of x here, so we need to make x the subject. So we can say 2x equals w minus 1, and x equals w minus 1 over 2. Okay. Correct answer here gets you the merit grade. You're achieved expressed as powers of 3. So this step up here would have got you achieved. Sweet. Moving on to question 2D. It says an equestrian jump has a parabolic arch mounted on a wall. Horses and riders jump through the arch. And we've got this diagram here. Scrolling down, the arch rises 2.43 meters above the wall. The arch can be modeled by a function of the form h of x equals kx times 3.6 minus x. K is a constant, h meters is the height above the wall, x meters is the horizontal distance from Q. Okay, a rail AB is placed above the wall, so that's this rail here, AB, and attached at each end to the arch. For one competition, the rail is placed 0.5 meters above the wall. So we could say, just in here, 0.5 meters. 0.5. And they're asking us, basically, they're asking us how long is the rail AB. Okay. So, we've got this equation, or it's a function, h of x equals kx times 3.6 minus x. And that might look unfamiliar to you. Basically, this is a quadratic equation, and we know that because we're working with a parabola here, but it's in the form, they call this intercept form. And so intercept form, it's not something I know a whole lot about, to be honest. I didn't really learn it when I did level 2. But it's why, apparently the theoretical version of intercept form, y equals a times x minus x1 times x minus x2. Okay, that's intercept form. And so that's what we're working with up here. Now, what does this mean for us? Well, we want to, we're asking for how long is the rail AB. So I guess we're solving for x here, right? Now k, we've got two variables, so we can't go ahead and solve for x straight away, but k is a constant according to the question. K is a constant, and so we actually want to find the value for k before we go ahead and find how long our rail AB is. So how are we going to do that? Well, we can substitute in the information for any point on our parabola. And so a point in this case is usually it's x comma y, right? Because that's coordinates. Here we're working with x comma h of x. And that makes sense. X corresponds to x, y corresponds to h of x. Okay, and so let's pick a point on our parabola. We can say that because the arch rises 0.43 meters above the wall, we've got basically that's our highest point. So we could draw a line like this, and here the height of this point is 2.43. And what is the x value of this point? Well, according to our equation, which is an intercept form, we have roots of 0 and 3.6. Now, assuming that a parabola, well, it is a parabola, and we've been told that it's a parabolic arch up right at the top here. Basically, it's symmetrical, right? And so if we halved it, the x change at the top of the parabola, in this case at h equals 2.43, the x value is going to be half of 3.46, and so the x value is going to be 1.8. So h of x is 3.6 here, and we can say x equals 1.8. Again, that's at this point here, the top, basically the maximum here. Okay, and we're going to substitute that into our equation. We're going to say, what was it? 2.43, right? Yeah, 2.43 equals k times 1.8 times 3.6 minus 1.8. And so here we can solve for k. We could say 2.43 equals 1.8k, and inside this last bracket, well, we know 3.6 minus 1.8 is 1.8 again, multiplied by 1.8. Okay, we're getting there. 2.43 equals 1.8 squared k, and therefore k equals 2.43 over 1.8 squared, and we can calculate that. Okay, 2.43 over 1.8 squared, that equals 3/4 here. So basically 3/4, or you could say 0.75. Okay, we've got our value for k. We can substitute it into our original equation. And so we're finding the value for x when the rail is placed 0.5 meters above the wall. So when h of x is 0.5. Okay, and so basically we're going to say 0.5 equals, our value for k was 0.75 times x, and it was 3.6 minus x. This is our equation. We're going to go ahead and solve for x. The first thing we can do is divide 0.5 by 0.75. That equals 2/3. So 2/3 equals x. And we can also expand these brackets here, right? So 3.6x minus x squared. We've got a quadratic here. Let's take everything to one side. Let's take everything to the left-hand side. Just to make our x squared term positive. So minus 3.6x plus 2/3. And actually I've ended up with a quadratic that's different to my notes. Hopefully it comes out with the same answer. We go into our quadratic solver and our calculator. X value is, A value rather, is 1. B value, negative 3.6. And the C value is 2/3 here. And so we end up with values of 3.40, x equals 3.40, and 195, and so we could say, yeah, let's write it. I don't really want to say 0.2, so 0.1958 here. Now we've ended up with two values for x, so what have we got here? I think these values for x correspond to the x values at a and b, right? And that makes sense, because if our initial point is x equals 0, then the x value for a won't be too much larger than that, and that is 0.1958. Similarly, x value for b is not much smaller than 3.6, and so it's 3.4. Okay, that makes some sense. Now they're asking us, how long is the rail AB? Well, we've got both ends of the rail. We are going to substitute basically the x values b minus a, and that will get us the difference here. Basically, that'll get us the length of AB. So length of AB, it is going to be 3.4 minus 0.1958, and that equals, what does it equal? That equals 3.208 meters. Okay, and so length of the rail found, that is going to get you the excellence grade here. Your merit forms a quadratic. So this step here gets your merit. And achieved finds k. So this, our first set of working here, gets you the achieved. Okay. That's us for question 2, it looks like. Maybe, no, it's not. We've still got E here. So question 2E, my mistake. It says interest is compounded on a principal investment, P dollars, at the end of each year. If the total amount of the investment after n years is A dollars, then A equals P times 1 plus R over 100, all raised to the power of n. That is the compound interest formula, where R% is the compound interest rate per year. Okay, so the first question here, Anushka invests $20,000 at an interest rate of 3.85, so A equals P times 1.0385 to the power of n. How many years will it take for her investment to be worth $25,000? So we're just going to use our formula here. We can say we've got A equals P 1.0385 raised to the power of n. And so our principal was the initial, so 20,000. It says how many years, so we're solving for n basically. Will it take for her investment to be worth $25,000? And that's the current amount. Okay. So this looks like $25,000 equals 20,000 is P times 1.0385, and we're solving for n here. The first thing we can do is go 25,000 divided by 20,000. I'm missing a 0 in here, aren't I? 20,000. That is 5 over 4. 5 over 4, or you could say 1.25, equals 1.0385 to the power of n. Now we have to use logs here. We're going to say, and let's even write it out, we're going to take log of both sides, so log 1.25 equals log of 1.0385 to the power of n. And actually this could be rewritten, knowing our log rules. This power of n can be rewritten as n log. I've skipped a step there, just to save us a bit of time. Hopefully that makes sense. At this point we can say n equals log 1.25 over log of this number 1.0385. Okay, and this is something we can calculate. So, fraction log 1.25 log 1.0385, close bracket. This gives us 5.91, and I was just thinking about whether the answer made sense, but we're talking in years here, and yep, that's reasonable. 5.91 years. And it says at the start of the question, compounded on a principal investment at the end of each year. So we've got to be careful about saying 5.91 years. How many years will it take for your investment to be worth $25,000? We are going to say it's going to be 6 years. We're going to say 6 years here, because it definitely wouldn't be anything less than basically 5.91, so we couldn't say 5 years. 6 years is the correct answer here. So that gets you a merit grade. You're achieved taking log of both sides and n as a factor. Log of both sides and n as a factor, so this gets you an achieved. Marking schedule mentions n equals 5.91 gets you an achieved, so actually you needed this 6 years for the merit. Okay. Question 2E2. Semisi invests his money at a different interest rate than Anushka's investment. Okay. His investment will double in value after 12 years. What is the interest rate? So what is R, basically, for Semisi's investment? So our interest rate formula is, and we could say A equals P1 plus R over 100 all raised to the power of n. Let's say I enjoy using A equals PR, R is the rate, to the power of T. Okay, let's actually use n, because that's the variable they gave us. Here, we've got P as a variable. The key to this question is if his investment will double in value after 12 years, we can say the amount after 12 years is going to actually equal 2p, because that's 2 times the principal, 2 times the original amount. Okay. And so let's say, inputting this information, 2p equals p. We're trying to find r, and n is going to be 12, right? It's doubled in value after 12 years. Okay, the first thing we can do is cancel p, because it's a variable. We're left with 2 equals r to the power of 12. Sorry, why did I write 13? R to the power of 12. Okay, and at this point, we're trying to solve for r. We can take the 12th root of 2, and it sounds pretty absurd, but that's what we're going to do. 12th root of 2 is going to be 1.05946. 1.05946. And so you might just freak out momentarily at this number, but if we think to the earlier question where it said we could say this piece of information here, 1.0385, that was our R, basically. That was our rate. Percentage-wise, it was R equals, where was it? Yeah, there it was, 3.85, so 3.85%. And so bring it back down to this question we're working on. R, in this situation, is going to equal 5.9, and we could say 946, let's say 5.95%. And that is our correct answer here. So interest rate found gets you an excellence. Achieved, merit finds, and I quote, 1 plus R over 100. So they did use that equation, A equals P times 1 plus R over 100. So our merit would come from basically this step here, I think, would be a merit. Achieved sets up the correct equation. So I guess the step here gets you an achieved. Sweet. Moving on to question 3. It says solve each of the following equations for x. The first one here is 12x squared minus 5x equals 2. So 12x squared minus 5x. And straight away, let's just bring this 2 to the left-hand side. It becomes minus 2. This equals 0. We could spend the time factorizing this. And, okay, let's do that. A value is greater than 1. It's 12. And so we're going to multiply 12, basically A by C. So 12 times negative 2 equals negative 24. So we're looking for two numbers that multiply to negative 24. And the same two numbers that add to the B term, negative 5. And those two numbers are positive 3 and minus 8. So we can split our B term now, 12x squared, into two parts, plus 3x minus 8x minus 2. So note that we have split the B term, negative 5x, into plus 3x minus 8x. Draw our line through the middle of the expression. Factorize the left-hand side. We've got a common factor of 3 x, and so inside the brackets 4x plus 1. Right-hand side minus 2 is a factor, and then 4x plus 1. And you know you're on the right track when these two sets of brackets are the same. This equals 0, so you've got 3x. And this is similar to the earlier question we did. 3x minus 2 times 4x plus 1. They're asking us to solve for x. Each set of brackets here equals 0. We can say therefore x equals 2 over 3 or negative 1 over 4. And so those are your correct solutions here. Again, you could just solve it on the calculating using the quadratic solver. Anyway, our second equation here, x plus 1 minus 3 over x equals 0. X plus 1 minus 3 over x equals 0. I think what we are going to do here, because we've got this nasty little fraction, we are going to multiply the whole equation by x here, times x. That is going to help us get rid of our fraction. So we're going to end up with x squared plus x. And we could even show this, 3x over x. And so our x's cancel, right? So if I just delete this, we end up with minus 3 by itself. That equals 0. This is something we can't really factorize manually like we did in the previous question, so let's just use the quadratic solver here. We've got A is 1, B is 1, C is -3, and we end up with x equals 1.3 and -2.3. And so correct solutions here, again, gets you an achieve. Okay. Moving on now to question 3b. Show that the graph of the function y equals 2x squared minus 5x plus c does not cross the x-axis. You must use algebra to support your explanation. Okay, so we see a question that talks about roots, right? It says does not cross the x-axis, and that means it's another way of saying no roots. No roots, or no real roots. And so we think of the discriminant here. So we're going to use our discriminant, b squared minus 4ac, and we're hoping that it is less than 0, because when the discriminant is less than 0, that means it will not cross the x-axis. So we've got our function y equals 2x squared minus 5x plus 6. And your a value, we can list them out. 2b is -5, c is 6, so we've got -5 squared minus 4 times a, so that's 2 times 6. Simplifying this, we've got 25 minus 4 times 2 is 8 times 6 is 48. 25 minus 48. And so we can calculate this. 25 minus 48, that equals -23. And so our discriminant is less than 0. Therefore, no real roots, or you could say it does not cross x-axis. Okay. And so here, explanation given, that gets you a merit grade. You're achieved. What's this? A star axis. Your achieved discriminant found. So I guess -23. Writing that down gets you an achieved. Sweet. That's us for question 3b. Let's move on now to question 3c. It says the equation 3x squared plus kx minus 12 equals 0 has two real solutions. If one of the solutions is x equals 3, find the other solution. So we've got this equation here, 3x squared plus kx minus 12, and that equals 0. And we see this statement has two real solutions. Immediately we think of the discriminant, but here, if one of the solutions is x equals 3, and we've been asked to find the other solution, we can actually use this x equals 3 and we can substitute it into our equation. If the question said, what's the other solution when x equals 3, straight away we'd do that. So they're almost trying to catch you out here, but we're going to use x equals 3. So we can say 3 times x is 3, so 3 squared plus 3k, right? Minus 12 equals 0. And so just tidying this up, we've got 3 times 9, which is 27. 27 plus 3k minus 12 equals 0. And so we've got some like terms here. 27 minus 12 is 15 plus 3k equals 0. So we can solve for k. We can say 3k equals, bring the 15 to the right hand side, so minus 15. divide by 3 on both sides, so k equals minus 5 here. Okay, so we've got a value for k. We're trying to find the other solution for the equation, so we can rewrite our original equation, 3x squared, and now we can say minus 5x, so we've substituted minus 5 for k here. Minus 12 equals 0. And this is something we are just going to use our calculator for. So a value is 3, b value negative 5, and the c value is negative 12. And so we come out with x equals 3, and we know that. We're looking for the second solution, and that is negative 4 over 3. Okay, and so negative 4 over 3 is the correct answer here, and that gets you a merit grade. Your achieved forms a factor of x equals minus 3 and uses it in a valid way. So that is basically, yeah, that's like a different method, right? They've gone about it another way. It says or finds k equals negative 5, and that's what we did. And that'll get you an achieved here. Okay, moving on now to question 3D, the last question of the paper, I believe. It says, show that the roots of the equation x squared plus 2 times k plus 1 times x minus k squared plus 2k plus 5 equals 0. K is a constant, can never be equal, so the roots can never be equal for any real number k. Okay, so we've got this equation, x squared plus 2k plus 1 times x minus k squared plus 2k, so it's a long function, 2k plus 5, and this equals 0. So what's going on here? K is a constant. It says show that the roots can never be equal for any real number k. Well, this first part, can never be equal. Not highlight, let's use red pen. Can never be equal. And so this question here, we are going to be using the discriminant. If the roots can never be equal, well, let's assume for a moment they are equal. And so the discriminant, if the roots are equal, and I can just draw this, I can illustrate this. Here, we've got two different roots. If the roots are equal, that means essentially there's only one root. It touches the x-axis once, like this, right? And so the one root is in here. And so when that is true, the discriminant, b squared, not capital B, lowercase b, b squared minus 4ac, that equals 0. So that's one solution. And that's what it's getting at with equal roots. And so let's go ahead and find the discriminant here. We've got our b value, and we can list them out. A is 1. B is, they've given it to us in this weird 2 times k minus 1. It's going to be, we can expand the 2, so it's going to be 2k plus 2. And c is this whole last part, k squared plus 2k plus 5. Okay. So we've got 2k plus 2 all squared minus 4. Now a is 1, so let's just forget about it. And we've got k squared plus 2k plus 5 inside the brackets. So this first bracket in here, we've got 4k squared. The b term is 2ab, so it's going to be 8k, I believe, plus 4. And we've got minus 4k, so expanding the negative 4 bracket, so in here, minus, not 4, but 8k, minus 20. Okay, we can collect like terms. We've only got a k squared term, just as 4k squared, so just one of them. We've got terms with k in them, and just our single integer terms. So we've got 4k squared, and that's actually not true, is it, what I said about the 4k squared? Looking at that, we've got this here. This is 4k squared, my mistake. So it's not 4k squared, rather it's going to be, well, it's going to be 0. So these two cancel. Same with 8k minus k. Now, is that correct? I'm just looking at my notes here. This should be minus 4. Okay, yeah. So we've got to think about, yeah, the negative sign in here. In our original equation, this is negative. So we have to include the operation when we're talking about a, b, and c. So let's go ahead and rub all this out, I think. And we'll give it another go. So our c value is, it's negative all of this, negative inside the brackets. And so we can say, inside the brackets, it's going to be negative k squared minus 2k minus 5. Okay. So we had 4k squared plus 8k plus 4, and then plus 4k squared plus 8k plus 20. Okay, so like terms, k squareds, the k's and the integer terms. So we end up with 8k squared plus 16k plus 24. And so what's going on here? This is our discriminant. Now, the second part, so we've only really addressed this first part, can never be equal. But the second part here is any real number k. And so we just said we don't actually know what k equals. And so here, let's assume for a moment that the discriminant, so it suits these terms, can never be equal, so it's not 0, but we still need to verify what this value k is. And so we are actually going to take the discriminant of this quadratic here. And bear with me, so I'll try to explain it at the end. Basically, we've got b squared minus 4ac again. If our discriminant is going to have roots, then k will be real. If it doesn't have any roots, the discriminant will look like this, and k will be, the discriminant will be less than 0. The parabola will look like this, and it will have no roots. And at that point, k is imaginary, so it's not real. Okay, again, bear with me. To be honest, I myself don't fully understand this question, but anyway. B squared minus 4ac. Let's list a, b, and c again. A is 8, b is 16, c is 24. So this shouldn't take too long. We've got 16 squared minus 4 times 8 times 24. So 16 squared, what is that? That is 16 squared, 256. 256 minus 32 times 24. So 32 times 24 is 768. So 256 minus 768 the answer is more or less irrelevant because we're talking about the discriminant here. Basically, it's going to be a negative number, so negative 512 is the answer. So this is a negative number. And so the discriminant, b squared minus 4ac, in this situation is less than 0, so it's negative. What does this tell us? Well, we said that this would tell us that there's no roots here, no real roots. And more specifically, no real values for k that suit whatever the expression is here. And that's almost irrelevant. This 8k squared plus 16k plus 24 is irrelevant almost, because we're interested in the nature of k, and we've proved by finding the discriminant of this quadratic, 8k squared plus 16k plus 24, that the discriminant of the original equation, now where am I going with this, basically is not valid because there are no real numbers for k here, they're imaginary. Okay, I'm trying to convince myself here. Anyway, I'm looking at the marking schedule, and that gets you an excellence grade here. In fact, there's two ways to get excellence. Correct conclusion would get you, shows discriminant less than 0 from the quadratic is your E8 in this situation. So I guess complete working gets you an E8 for the question. E7 concluded that there are no real roots with little or no working shown. Okay, I mean, look, little to no working. I guess let's just say here E7. And actually, while we're looking at the marking schedule, it says no real roots, and hence no values of k for which the original equation has equal roots. Right, okay. Anyway, merit simplified quadratic set equal to 0. So this quadratic here, we've got to say that's equal to 0. Because we're talking about equal roots. Correct, achieved as correct discriminant substitution. So the step here, this is your merit, and correct discriminant substitution gets you an achieved. Okay, sweet. Now let's leave it at that. I urge you guys to go and look at the marking schedule for this question, and maybe you can definitely understand it yourself, and even help everyone else to understand it as well. Anyway, I think that's us for the paper. Yep. So, as always, I hope you guys enjoyed it. Any questions, comments, leave them in the comment section below, and I will see you guys next time. Cheers.